So Otto is an engineering manager and software architect at Global Web Index, and he will talk to us about the compression puzzle challenge, which is a coding puzzle that challenges the best programmers. And we'll look at solutions, compare notes, and hopefully be inspired to explore new technologies. And Otto, the floor is yours.
Thank you. Just can you please confirm for me that you can see my screen? So I'm in the loop. Okay. So yeah, some thanks for introduction. So I'll try to be time cautious. If this thing tries to run over the time limit, remind me, and I'll try to shorten it, and I'll try to skip some examples or whatnot. Thanks for coming to this presentation. I'll try to present a project that I've been working on with my friends for a while. It's called Compression Puzzle, and it started as a in-office joke, and it escalated to quite extensive proportions. When I was thinking about how should I present this and what should be the focus and the main theme of this puzzle, and how should we go about it, I realized that perhaps like traditional coding puzzles or traditional coding goals either focuses on the shortest solution or the fastest solution or some other aspects of what would make one's solution great. But in this case, I tried to find not just like the best solutions and the given space for the given task, but also like visually the most appealing, technically the most sophisticated, the best looking aesthetically based solutions. And my talk today will revolve around these themes, and I'm going to start with a quote from Edgar Degas, and the quote goes, "Art is not what you see, but what you make others see." And this theme is going to be common through my presentation. So I'll introduce you a bit to this artist. So he was a very famous artist, or is very famous artist from French. And he was really famous because of his portraits and pictures of dancers. So around 50% of his pictures were actually dancers, ballet dancers trying to learn the craft of actually dancing. And although he is kind of like an impressionist, he didn't want to be known as impressionist. He said that he is realist. I see there is a lot of common themes between the authors of the challenges that you're going to see today and what this guy did. And I think these things are very connected. So I'll try to follow that common theme. And yeah, his paintings, if you ever seen it, they look like this. So you have dancers in different poses. They're trying to do their best. They're trying to learn the craft. They're trying to really excel at what they do, and they're trying to train together, learn from each other, and they just try to be the best at what they do. So I'll talk a bit more about the challenge itself. So the story goes like this. I have a friend called David, and he brought this programming puzzle to our co-working space, and he just wanted to see what different solutions he might get out of us, just on a Slack, and that escalated. We started with 2 solutions, 3 solutions, and then at some point he had like a good taste of what's possible with the solution, and then we scaled that up to make it like an open source project, and we defined rules and we defined the CI pipelines for this, and it really exploded from there. But the essence is this. So it's a programming puzzle. You get an input string, as you see it here, and the programmer needs to write a function or a program or an expression that will give you kind of like a compressed version of this problem. So like if you are a beginner programmer, if you're an intermediate programmer, or if you're like a expert programmer that works for Google, you can kind of like grasp the idea quickly, and you can really write your different solutions for this problem. And just by by being engineers, being on this meetup, you probably already know how to approach this problem, and you might have very different approach, but you'll still be able to crack this challenge. And after you crack this challenge, the natural progression from there is to how can I make it better? How can I make it more elegant? How can I make it shorter? How can I make it more performant, etc. But usually, like if you're a programmer, if you're a programmer in profession, you'll surely understand understand the problem well enough. And yeah, like I said, this started in as a joke. It started in like a local environment within friends. I then invited people from my wider network, and from there on, it kind of like got interesting within these networks, and it really expanded. So a lot of very experienced people have tried to do their best to solve this. But yeah, in essence, I want to show you how far you can go with a simple idea if you start collaborating with people. Yeah, just to warm up, given that this is a Python meetup, I'll start with Python examples. And this is, for example, something that, you know, somebody that's learning Python or somebody that's using Python in production, and it's not like an expert or whatever, would reasonably understand and would, you know, would be easy to grasp for him. So you have a loop, you loop through a character, through a set of characters. Then you have some additional counter that tries to count at which position the character is appearing. Then it tries to mutate some state somewhere, and then in the end, it tries to combine this array into a final output. Nothing fancy, although you might not currently be working on implementation. You understand that there is like a loop, and this loop has to do something within the iterations that happen. Nothing fancy. Again, if you would saw this code within your Python project, you would immediately understand what's happening. And then if you have loops, you can then make your code better with another level of complexity by introducing recursion. So this is an example written by Brodo. You can see that this function uses recursion, and it still uses mutation of the data while the recursion is happening. And it also uses Python's function for unpacking array into a head and the rest. So again, a bit more sophisticated example. And the author here also tried to convey what's happening through the comments, which is also very useful if you're trying to follow somebody's thought. And from there, it can become a bit more sophisticated. So if you have recursion, you can optimize that recursion in a special way, in a way that's called tail recursion, where the last thing that the function returns is actually a call to another function. So you can see here that Luca's example, this is now being introduced, and again, it's the same solution. It will output the exact same thing that it needs to, but it's just another step away from the basic example. Now we saw like basic Python that will do the job, and it's nothing wrong with it. But then things could become easier or better if you try to introduce more stuff from your standard libraries, or you start introducing more complex things. Just given that you need to have set of rules when you try to do challenges like this, we said that the only constraint is that you need to use the language, whatever the language is, and the standard library that comes with the language. So no external libraries are allowed when you write these examples. And in this case, you have two examples. One is using GroupBy, that's part of intertools in standard Python's library. And the other example underneath it, it's a very famous example where the programmer is using Python's list comprehensions, which are very powerful set of tools when you're doing with collections or arrays. Both of these solutions, again, return the same thing. The the for comprehension example might actually be a bit faster. But yeah, and yeah, when you try to like come up with these solutions on your own, you're kind of like you're bound by the knowledge that you have. But once you start to collaborate with other peoples, you can also start learning from them. And this is an example that Urban Škudnik submitted, and he saw some of the examples that you guys saw, and he thought that he can improve them. And here you can see two Python solutions, one iterative and one recursive. In the recursive, in the iterative example, he started using Python's take while function with lambda expression, just so that it kind of like becomes a bit more sustainable and easy to read. Again, a very powerful solution here indeed. So yeah, we can go further with Python solutions. So this is another Python solution here that uses lambda functions, expression, and in this given example, the author also tried to cheat a bit, and instead of writing all this logic of trying to break the string apart, he wrote a regular expression with look behind. When this example came in a discussion, we started discussions that this is perhaps, you know, should be thought as a not as a cheating, but kind of like not really the right approach when you try to come up with a sustainable code or whatever. But still, like trying to mix different things when you're trying to create something interesting, it's an option when you're an engineer, and you can see that regular expressions can also make a really beautiful solution. Now, if I go back to Edgar, he was master of oil paintings and chalk, but he also did sculptures. So this is one of the examples of his dancer sculpture. And if he was able to transcend just his original tools, it's also interesting to extend this puzzle to other languages, right? So we can do more. And the first language that you know you should know if you're in web development is JavaScript. So here you have two examples from David Litchen. Both of them are written in modern JavaScript, and you can see that on the left example he's using for each function, and then he learned that it's possible to write this with more sophisticated function, and he introduced reduce function as well. So, and that kind of like made his solution a bit more elegant as well. And you can start appreciating different approaches, and you can also learn that if people are really masters of their craft, they can really pull together really sophisticated functions or mechanisms that the language offers, and they can come up with really nice solutions. So this is a solution from Klemen Kugoshek. It uses very modern JavaScript, and you can see this, for example, 3-dot notation, which expands the string into an array of characters. And you can also see that, for example, he's not using if functions anymore. He's using so-called ternary operator, which is essentially kind of like better way of expressing if statements. So no loops as per definition, and no if statements are present in this JavaScript solution. And you can take it even further. So if you spend more time with regular expressions, if you start to learn more of this like modern way of how regular expressions work, you can make even shorter solutions for this. So this is a solution from Luca Prebil. And yeah, it uses regular expression, and you can see the author really went for minimalism here as well. And yeah, now you saw that we have like Python and JavaScript, and we have different authors trying to compete. They're trying to do our best. They're learning from each other. So the next obvious thing would be how can we expand this game even further, right? So yeah, the obvious thing would be to introduce more languages, right? So here you have two Go examples. One is from Tit Petric, another is from David Kurija. The one on the both examples kind of like feel the same, but since Go doesn't have like these high level functions, you need to use loops. You still can use ranges. And it uses, for example, this rune, which is a very Go specific thing that you can use within Go. And these examples, for example, might be faster than Python's examples, given that the authors choose to use Go as the language. Yeah, perhaps before we go into more extremes, we can appreciate a bit kind of like traditional languages. So on the left side, you have Nate Stutz's solution in C#, so modern C# that uses LINQ library, which is kind of like embedded language within C# to do like very nice computations on top of data. So you can see that you have aggregation, you have selection, so functions that you might know from languages such as SQL that are getting introduced into the code base. And on the right hand, you have a solution taken from Alex Justin and Peter Levert. These two examples are written in Java. They're taken out of bigger context. These guys also experimented with parallelization and trying to do this computation really fast. If you're curious, I'll provide more information. But again, you can appreciate that these authors, for example, didn't really optimize for the aesthetics, but they optimized for performance and parallelism and trying to crack that aspect of this challenge. So now we see that like more and more elegant or interesting solutions try to emerge if you try to just like play along. And I'll introduce now like collection of examples that I call that they're like purist, because like their solutions are very pure. So they use functional languages, they try to use pattern matching, they try to use very sophisticated techniques to really crack the problem in its essence. So for example, here is a Haskell solution from Marek Fajkus. If you've never seen Haskell, this is how Haskell looks. And for example, this operator on the bottom, just like if you've never seen it, it's called bind operator. And you can see that you see some elements like folding, which is, you can think of it like a reduce, and you can see that the author here still uses some expressions, and some elements might be familiar to you even if you don't know any Haskell, but again, you can appreciate the elegance of Haskell. There are some new players that, for example, try to play it safe when it comes to memory. So this is, for example, a solution in Rust written by Simon Slender. Interesting thing that this solution shows is that, for example, you have this pickable function which allows you to look the next character within the iteration, and that kind of like simplifies the whole thing even more. You can see this next if equal operator again that can make the whole thing even nicer in essence. Again, this might be, for example, very performant, very type safe and everything solution. Following purists, this is a solution written in modern Scala language. This is a solution I wrote. It uses pattern matching to expand the current sequence of characters, and then it uses some other techniques to bring this whole collection back together. But again, you can see that, things are happening within this solution. Now, now that we're dancing and we see like these solutions, but you're like, these are crazy solutions. There's no way that if I saw these solutions in my code base that I'll be able to understand them or even maintain them. So I guess we should focus more on the elegance or like making sure that solutions are like understandable and easy to grasp. So I'll show a bit more the elegant side of these solutions. So this is a solution, for example, written in Ruby, and you can see that given that Ruby is like very verbose language, has extremely powerful standard library, and it has very good support for dealing with arrays or collections. You can see that again, Christoph's solution here. It's very elegant, very maintainable, and you can, if you read it out loud, you can understand what's going on. And you know, one of the mantra of Ruby is that if you can read the whole expression out loud, then you should be able to figure it out. And I think this expression demonstrates that. One interesting point here with this function or this example is that _1, that would mean that the first attribute that map function gets, you can use it. You can see the same example, for example, in modern Swift language. I think this is called enumerated parameters. And yeah, this is another example that Roman built. This is a solution that uses R. You can see that, again, it's very simple, very easy to grasp, and you can instantly get the idea what's happening. Although I don't understand this identical stop if not, but yeah, I guess if the function does what it says in it, then it should be good. Yeah, people started to use more of their tools. They started to use this very uniqueness that languages bring. So in this Elixir solution here, you can see that compress function is defined 4 times. And essentially in Elixir, you can do this like very smart method overloading where you have different functions defined in this way. Again, a very interesting approach that can only be implemented in Elixir, for example. Then you have other kind of like branch of languages. So in this case, you have a solution that's been submitted by Simon Belak. So you can see closure. Here you'll see functions like transduce, partition by, mapcat, etc. So, and a lot of brackets, obviously, since it's closure. But again, you can see that it's kind of like inline. If you know closure, you'll instantly understand it. Then you have other languages that are very popular. So this is, for example, Milan's solution in Lua. And then you get to even more esoteric languages at some point. So this is, for example, another solution written by Chaya and Boris. And this solution is written in programming language called Red, which is the next language after Rebel. So again, it should feel similar to Ruby, so it should be expressive, and you should be able to figure out what's happening if you're familiar with this language. But again, you can see that it's a one expression, one liner, and does the whole job. Okay, now so we're now dancing, things are getting really excited, and yeah, we understand what's going on. So it's now time to go even further and even beyond what we currently saw. And I'll show you this example. So this is an example written by Janko Metelko. This example is implemented in programming language called Rai. Rai is a new programming language that's developed, and it's being developed by Janko himself. He wrote this example in his own language, based on some examples that he saw implemented in other languages. But yeah, specifically in this languages he's building. And because he was like tracking the progress of how other solutions were being made, how other languages evolved, there's how other authors evolved their solutions by invoking like these super functions that other more powerful languages or high-level languages have. He then decided that, well, it would be interesting if my language would, for example, support high-order functions. So he went back to his programming language called Rai, and he extended his programming language so that he could implement this solution that you see now on your screen, which is, for example, compress B and compress C. these functions were added to his programming language so that he could solve the solution in a way that he wanted to solve it. So now we're like really going beyond. Yeah, kudos to Janko on this. And not stopping there, SQL is also a programming language, so fourth generation of programming language. Here you have two solutions, one done by Nazi-Stutz and another done by Janko Metelko. Both of these solutions are implemented in SQL. One is in Microsoft SQL language, and the other is in SQLite. So again, if you would run this example, you would see that. I'm seeing some comments. Yes, there is a solution in C++ also already. Okay, I'll talk about numbers here a bit. So again, the whole concept of this idea or this project was to have fun, to explore what's possible with this language, to challenge different programmers, to challenge the really best programmers that I know or could be reached. But like there are attempts, for example, to benchmark these solutions. So there's like a benchmark suite that benchmarks just Python solutions. Some authors decided to really go to extreme. So you'll find benchmarks, but there is no benchmark that would go through all the solutions and just point out which solution is the best. And again, we were trying to. It should be like a learning experience, and people really learned a lot by submitting this thing, by playing along. And I think, like, again, we're really trying to see like how elegant solutions could be made. But still, I have some of the numbers here. So currently, to this day, 34 authors have participated in this challenge from different countries. There are currently 3 open pull requests that I still need to merge and review. There is now 86 solutions. So this is like this number might be even higher than 86 because some solutions are implemented in Wildfile. So there's, but yeah, around 70 solutions and 27 different programming languages. Yeah, I think we cover most of like modern programming languages. There's also a collection of languages that I would like to see that has not, and but yeah, this has evolved. And again, I'm if you are appealed by this challenge, if you want to submit your challenge, if you want to compete with this stuff, please make sure that yeah, join in and learn from it. And yeah, so this is my last slide. I made a QR code, so if you want to scan it up and look it up in your phone, you can get to the GitHub repository and you can see all the solutions. The link is also there, so if you just follow the link, you'll also get there. Yeah, there's on GitHub repository, you'll see this like basic rules that you should have fun, that you should challenge yourself, and you should submit as many solutions as you want. Then you're not bound by the language. Although I needed to then make this rule. I tried to run these examples on a CI server, so everything is run through Nix and Makefile. So I encourage authors to also use that framework to test. There are also now 2 blog posts written about this stuff. So if you really want to go into details about how some elements are implemented, so how certain things work, comparison of these things in quite detail, you can go to this epic blog, my blog, and you'll find this article that describes all these solutions and some detail. And yeah, that's essentially it. Any questions?
Yeah. Do you have the Python solutions benchmark numbers handy?
Yeah, I do. Yeah, I do have them. So I think I can just find them. I think it should work. So yeah, you have some examples here. You can see that this solution that Broder wrote, so not your solution, but solution that was presented after yours. that was based on these benchmarks was the fastest. For example, yes.
Okay, so the least comprehension was not the fastest, because that's you would.
No, yeah, I would encourage you guys to just go to the repository. There's like a benchmark. You can run this thing yourself. And yeah, everything is written there. I'll open the repository just to have some background.
So actually, least comprehension was the fastest. I don't think this is sorted.
Yeah. The list comprehension solution is the fastest within those examples. Correct.
So the one that uses group by.
Okay, so
which is understandable.
It's really fun to see the like diversity of the Python solutions.
Yeah. Python solutions. Yeah.
And they're really like, none of them are really similar to each other. I think they're actually, there's actual like diversity, and it really showcases the different features and the more functional approach. And we even have like, I think we had 2-3 different types of uses of recursion and stuff, and that was really, really fun to see.
Yeah, that's the aim of this. Although it might sound like a silly thing, it's really like, it shows that like if you have like a simple idea and you try to at least put some rules around this idea, and if you try to just push it just a bit, then interesting things happen. And this is one of those examples. And again, yeah, almost 40 people have submitted their solutions, and that's more people than there are currently on this call. Just like so, yeah.
No, yeah, I think I can speak for everyone that this was really fun to listen to.
Thank you.
Basically, it's like a commercial. I think it's like almost like a commercial for Python, because Python has 9 solutions and the other languages have like 3 at most. So that's really saying something about it as a language. I mean, okay, we can start like this whole discussion of how it's not opinionated enough or whatever, but I will take it as a commercial.
Yeah, I mean, there is a lot of solutions here. I couldn't, because we're time bound, I couldn't present everything. But you have solutions in F#, you have solutions in .NET, you have solutions in Java, and when you're running these things in production environment, then JVMs or .NET, all these things would need to be warmed up. And these are like very synthetic examples, and so it's not really fair to compare them to each other. So again, I just wanted to show like how different approaches, different functions, how this all shows, and how like this like beauty comes in different shapes and forms, and that should be the main theme. There are some questions about how do we benchmark. So for Python, there is the script here, benchmarks.py. It uses time it, and it uses this time it, and then it runs it. I'm not like expert, but I think it does 10,000 times, and that does it. There's also benchmarks, for example, for F#, that the author really benchmarked it against. You can see 100,000 solutions, and you can, the game of benchmarking is game on its own. And currently nobody was brave enough that would benchmark every solution in existence. You also need to understand that some of these languages require compilation. Some of these languages can be interpreted. Some of these languages have runtime environments, etc. So it's not fair to just compare them to each other directly.
Yeah, that's
cool.
A good point.
We need a smart contract solution. Yeah, I'm waiting for Yuri to submit his smart contract solution for this in Solidity. We're still accepting pull requests. So Yuri, if you're brave enough.
Yeah, submit your own solution if you're brave enough. Any more questions? Okay, there's one.
Okay. Can
Okay,
it be done with C preprocessors? I mean, go for it. Probably, I don't know. There is solution in C, submitted by one really good engineer. Yeah, it's here. Something like this. Don't ask me to explain it. I'm not that good in C, but yeah, apparently this stuff works. Yeah, there are some questions like you know people are like asking, for example, how should they also implement decompression? How should this algorithm work if there is like if it's a short string or it's a really long string? Should like how would all this work? And yeah, there's a lot of edge cases and yeah, I just try to do like have fun. I guess that's the main thing here. Cool. Okay.
Yeah, Yuri is also wondering if he can do it in CSS, and that sounds like a nice challenge as well.
If you have a way of if you have like way of calling something either via in a loop or recursion, and you have some way of accumulating things, then yeah, then probably it could be done in CSS. Although I cannot visually imagine how would that look like. But yeah, I would really like to see this stuff being implemented in assembler, for example. So assembly language, that would be interesting. It would also be nice to see this implemented in some esoteric language, like I don't know, brainfuck or you know these really obscure languages. But yeah, if you, or Fortran or COBOL or you know one of these like languages that it's hard to find engineers. But yeah,
Yeah, so if there's anyone who'd like to submit one of those obscure solutions, go ahead. Otto will be very happy.
yeah, sure.
And thank you very much.
Here's the blog post, and it has like more stuff too.
Okay, yeah, check out the blog post and the GitHub repo.